Dear students, today the topic will be on complex formation. Okay, the subject itself is the physical-chemical, the chemistry part, the environmental chemistry part. So, whatever maximum chemistry is dealing with this subject, or the chemistry is dealing with the environmental engineering will be taught in this subject. Okay, I have already come across your basic fundamentals like the concentrations, molar concentrations, then the equivalence, everything. Then we have come across all the chemical parameters, the molar concept, then the chemical balance, and another one regarding the chemistry. One of the most important part of environmental engineering is complex formation means it is for chemicals. You see over here, I'll give you one example. Environmental means pollution. So many heavy metal ions like zinc, chromium, chromium there is 3 is there, chromium 6 is there, lead, copper, mercury, and cadmium. Okay, a lot of heavy metals are there. They are very, very toxic to us and they are termed as heavy metal ions. So it is very important for us to remove the heavy metal ions or any other chemicals, okay, from the wastewater, and especially these are from industries. Say, for example, zinc, copper, you'll get it from electroplating industries, okay, and then this chromium you will get it from leather tanning industries, lead, it's all battery. So a lot of industry gives out a lot of heavy metal ions and it pollutes the environment and it increases the toxicity of the groundwater and many issues. Now, from this subject point of view, how to remove all these heavy metals? There are different techniques. One is, some of the examples are, it can be removed by adsorption. So this will be coming afterwards. Then another one, very simple, is a membrane techniques. Membrane techniques like what you have said these days, reverse osmosis, and then reverse osmosis, then electrodialysis, okay, using membranes. And another one is, the simplest is precipitation. Every heavy metals removal technique, they have their merits, they have their demerits. That's a different thing. From this topic right now, we are going to choose this first, precipitation. I'm not going to decide who is better or who is the worst. No. We have to learn the basic fundamentals of these chemicals, the complex formation from the environment, how to remove by using precipitation. Okay. So theory way, precipitation is nothing. It is a conversion to insoluble. All these heavy metals will be in a soluble form in the water. So how to convert it into insoluble, right? So some of the converts say it is converted by using hydroxides. The best example is, you say if zinc is there, you say zinc hydroxide, you convert it copper hydroxide. Okay. Any metals, heavy metals, you increase the pH, convert it to base, and then it'll become precipitate. These are all precipitate, correct? We call it PPT. Fine. So this hydroxide, the more you put base, they'll become insoluble and they'll start precipitating out. And this all these precipitations, it can be settled at the bottom or you can filter it out. The logic is conversion of the soluble into insoluble. Okay, so this one will do. Some other examples are there. This is converted to sulfides. Cupric sulfide, chromium sulfide, zinc sulfide, cadmium sulfide, lead sulfide. But the most easy technique we use is the simplest is hydroxides. Okay, so before teaching the topic, I'm just giving you the basic fundamentals. Why we are going to learn this topic? This topic we are going to see how we can make hydroxides for any heavy metals so that we can convert a soluble heavy metals into insoluble. Once it becomes insoluble, we can precipitate it out. We can filter it out. We can screen it out. Okay. What are the difficulties you face during the precipitation? The complex formation that will be teach. Okay. Okay. So first of all, some of the chemistry part, what we have to know is, first thing is this zinc. Okay, I'll give example with the zinc. So we are going to learn what happens between the chemistry of the zinc and the hydroxides. Is it just that it is jet and OH2 or it's something else different? Okay, so let me come up with that. Okay, first thing is what you know is we are going to study the formation of zinc hydroxides. Now, first, when zinc, this is the most simplest thing what we've learned. Okay, zinc hydroxide. When this zinc hydroxide, this is in the form of a solid, it can be ionized as zinc plus twice molecule of OH. Okay, fine. So whenever you have a zinc hydroxide, it dissociates into Zn plus 2 and twice molecule of OH. This is the first equation. Now, based on this, what we have seen is this zinc ion in the water itself, if it is soluble, sometimes it is in the form of Zn plus 2 zinc ions. So this zinc plus, okay, the first molecule is we are trying to add hydroxides. Let's say you add hydroxides either by adding sodium hydroxide or say calcium hydroxide, whatever. You are adding hydroxides. Our point is when we add the hydroxides, how the zinc reacts. Okay. So first, when zinc is react with hydroxides, it forms ZnOH plus. Okay. And this ZnOH plus, it is with another hydroxides we keep on adding and we got ZnOH2. Okay, this is number one equation. Number two equation, the number three equation is When Zn is again OH2 reacts with OH, it forms ZnOH3 minus. Just let me write it down first. I'll explain it. You don't worry. When ZnOH3 is added with another OH molecules, it forms ZnOH4. Okay, fine. So, see, this topic, what I'm trying to explain is when you add hydroxides to zinc that is soluble in the water, it is soluble in the water. What happens to this zinc? When you add hydroxide more and more, it is not that directly it forms ZnOH2. It is not that. Fine. It forms firstly the OH2, OH3 minus, OH4 2 minus. These are different species of zinc. These are different species of zinc. Okay, and these are called complex. I'm not going to explain how does the bond formation is covalent, coordinate, ionic bond, wellness bonded. That's too much of chemistry. So when zinc is mixed with the hydroxides, when we try to increase the pH, this type of lot of complex formation is there. Number one. Okay. Now the question comes, where is the part that is going to become precipitation? And all this zinc 1, 2, 3, 4 are all in soluble form. They are in soluble form, and our target is trying to make it insoluble. Okay. So we know that if pH increase, ZnOH2 is there. ZnOH2 is actually in precipitate form, in insoluble form. But the thing is, if you add more OH, again it comes in ionic form, in soluble form. Okay, so for the pH, for OH to make precipitate, we are making OH. Number one, the factors are, can I say, you are adding more and more OH means pH will increase. Therefore, can I say pH is one factor? Am I correct? So rather than saying increasing the OH value, we can say pH is one of the factor that's going to explain the solubility or the insolubility that's going to make the precipitation of the complex zinc, right? Let me repeat it. pH of the solution is one of the factor that is going to decide the precipitation or the solubility and insolubility of any heavy metals. Fine. Number two, it is not that a pH example say 8, zinc is precipitate. It is not that it will precipitate in pH at all the time. Another factor is there that is called concentration. More of the zinc ion concentration, very, very high concentration, solubility may be more or less. I'll give you one example. You have a cup of the water. You try to take a sugar, you add it, you stir it. The sugar will start dissolving it, it will convert into soluble form, correct? But the more and more you add sugar, the capacity of the water, that is this OH, will be over to make the sugar soluble anymore. So the more and more sugar you add in a cup of tea, finally the sugar will not be able to get soluble, correct? That means the solubility of the sugar also depends on the concentration of the sugar, right? Similarly, the concentration of the heavy metal ions are also responsible to make it precipitate. That means whether it is soluble or insoluble. So these two things we are going to study in this part. So these are the four. Next point is, you may ask me, sir, what about ZnOH5 minus 3? Fine. It is that till here it is learned by scientists who have discovered it. In the future, if it discovered, many may comes. It's a very silly explanation. Another one is higher complex formation are very insignificant because there is a topic called the solubility product, which you have learned in class 11 and 12. The solubility product that I'll explain again. So higher formation of complex is very insignificant. And mind you, it is not that always it will be OH4 minus 2 for zinc, copper, mercury, lead. It may not be. For different heavy metal ions, it's different. Okay, fine. So this is the concept I'm telling you. Now we are going to see at what pH zinc is going to precipitate, number one, and number two, at what concentration is going to start precipitating. So that you have a particular industry, you're saying, sir, my industry is leaking out, say, 50 milligram per liter of zinc in the water. So what should the pH be so that I can precipitate it? Okay. Example is you have got your industry, the effluent treatment plant. Okay. And you may ask me, sir, my zinc in my wastewater is say around 150 milligram per liter. So what pH should I maintain? How much hydroxide should I maintain so that all this soluble zinc I can precipitate it out? That's the thing we are going to study over here. I'm doing example for the zinc. I'll give you an assignment. You may do for other heavy metal ions. Okay. Is the concept clear? Why we are studying this topic? Okay. Another point what we know over here is, okay, so from this equation, what we have learned is, since it's happening in the water, we should have this equation also. Okay, another point what you have to learn is, this thing, if reactant A and B is done to form B, okay, the K value. The solubility product what we have is C. Okay. So if any two reactant is combined to form the product, what I'm saying is the product divided by the reactant is constant and then it's a solubility product. Say for example, over here, what you know is H into OH. Okay. I think All of you can make nonsense, right? So for this equation, is it okay? Have a look, then I'm going to write the values. Okay, so for this, what happened is, this symbolized the molar concentration. It's equal to K1. Okay, I'll give the value for these things. Look here, JnOH divided by JnOH, the product, is the solubility product 1. Similarly, for a second equation, JnOH2 divided by JnOH plus and OH is K2. Okay. Similarly, for this equation, JnOH3, then the product is JnOH2 OH is equal to K3. I'm going to come. Then the final is JnOH4 2 minus divided by the reactant JnOH3 minus into OH is equal to K4. Okay. And you don't worry, all this has a value. This is 1.4 into 10 to the power 4. This is 1 into 10 to the power 6 is equal to 1.3 into 10 to the power 4, and K4 is 1.8 into 10 to the power 1. Okay. Remember, these values, it is not made by us, it is a solubility product, it's a constant. Okay. So I think I can rub the upper part. This part is okay. Now for this, what happened is, for this, Zn into, this is twice molecule, so it will be in the form of 2. Okay, whatever here, it will be in the exponential form. This is solubility Ksp. This value is 8 into 10 to the power minus 18. These values, even in the exam, you don't have to mug it up. We will give you everything. Now, let me explain you once more again. See here, when zinc becomes soluble in the water, the first complex zinc forms with the OH is zinc OH plus. Zinc OH plus further connect with the OH and form the zinc OH2, the neutral ion. It's not ion. Zn OH2 again mix with the further OH and form zinc OH3 minus, and similarly zinc OH4 minus 2. These four are different complex that are formed in the water when zinc mixed with several OH ions. So this is another one. Now, as per this environmental chemistry, this value, what we know is the solubility of zinc is this zinc into OH2. The solubility is 8 into 10 to the power minus 18. These values are already the standard values. It will be given in the book. it will be given in your exams for any chemical alliance. Say, for example, hydrogen into OH is called 10 to the power minus 14 is constant, right? That's why our pH cannot be more than 14. Similarly, for the formation of this complex, the red constant is 1.4 into 10 to the power 4. So the product is the ZnOH2 divided by Zn into OH. And this bracket symbolize, I told you already, molar concentration. Okay. Similarly, the final formation of complex ZnOH4 divided by the reactant ZnOH3 minus and OH is K4, K1, K2, K3, K4. Why I'm saying, because this makes us aware that okay, the formation of the zinc complex is in 4 steps. That's why we put a value K1, K2, K3, K4. K1 is the first step, second step, third step, fourth step. And K4 is a constant of solubility for formation of the fourth complex, ZnOH4. Okay, this value is already well known fixed. Okay, now we are going to see we are going to see this complex, these ions. See, 1, 2, 3, and 4. These 4 ions, they have some value. We have OH also. Indirectly, oh, what is OH? OH is nothing. OH is indirectly related to pH. Am I correct? So, how this complex are going to react at different pH, that we are going to estimate. Is it clear? So, let this be there. I'm going to start a work. Okay. So, let me rub this side. Let me keep this one for time being. When you look here again, we are going to find zinc hydroxide, OH, OH2, OH3, OH4, and this zinc, we are going to find what will be the value at different pH. Fine. First thing is, where is my calculator? I have to make the things ready. Okay. Number one. C. Zn2 plus into OH ions. This is 2 molecules, so 2 should be here. 2 is equal to 8 into 10 to the power minus 18. So taking log, therefore, log of Zn2 plus, if you take both the log, plus 2 log of OH is equal to log of 8 into 10 to the power minus 18. Right. Log of zinc 2 plus is equal to log of 8 into 10 minus 18 minus 2 log of OH. Log of Zn2 plus is equal to, let it be, log of 8 to the minus 18 This is minus C. I'll give you another example here. pH is equal to negative log of H plus P. Potential of OH is equal to negative log of OH. Remember that. Okay. So negative log of OH means I'll say this is 2POH. Correct? So it's equal to log of pi to the 10 minus 18 plus 2. POH is nothing. 14 minus pH. Correct? As simple as that, I can say pH plus POH is equal to 14. Okay. So this is log of 8 into minus 18 plus 28 minus 2pH. It's equal to 10.9 minus 2pH log of Zn2 plus. This is equation number 1. Please have a look. Please have a look. Now, firstly, we define that by taking the logarithm. We calculate, we obtain that log of any Zn2 ions. Zinc is in different forms. Zinc can be in the form of Zn2 plus, ZnOH plus, ZnOH2, ZnOH3, ZnOH4, 2 minus. So one of the zinc, log of zinc from the solubility product, what we obtain is, it is 10.9 minus 2 pH. Fine. Say for example, at pH 2, at pH 2, 2 to the 4. 10.9 minus 4 means 5.9. So, and pH 2, Zn2 plus will be, the concentration will be, the logarithmic concentration of Zn2 plus will be 5. 10.9 minus 2 to the 4, 5.9. I'm just giving one example. Let me write over here. And, but don't write this. At pH is equal to 2, say example. Or say at pH is equal to 8. Log of Zn2 plus will be 10.9 minus 2 8 16. 10.9 minus 16, it will be 5 minus 5.1. Correct? So that means zinc will be 10 to the power minus 5.1. Is it okay? So from this concentration, what we know is at pH 8, Zn2 plus will be, the concentration will be 10 to the power minus 5.1. If the concentration is more than 10.5 minus 1, it will become insoluble. Is it okay? So let me write over here. So for Zn2 plus at pH 8, concentration is equal to 10 minus 5.1. If concentration is greater than 10 to the power minus 5.1, it will be precipitated. It will become insoluble or precipitate. Is the concept clear now? This is just one example I'm giving. So at pH 8 means 2 8 is 16, 10.9 minus 16 is minus 5.1. So Zn will be 10 to the power 5.1 because this is log. Okay, so 10.5.1. So at pH 8, if the concentration is 10.5.1, it is exactly in the center. If the concentration is greater than that, 10.5, 10 to the power minus 5.1 moles, it will become insoluble. Is the concept clear? So this is just one example I'm giving. Okay. So you can pause the video, you can have a look. Let me check still the video is recording or not. Yes, 35 minutes is gone. Fine. So let me rub this part. Let me rub this part. So uh, even I need to, I'll forget this part. Well, I have to write this one for myself because I'm not able to hear what you said. So I have to write here. So rather than this, let me rub this part and let me write it here. Log of Zn2 plus is equal to 10.9 minus 2pH, number one. Okay. The second part is I have to find this ZnOH plus ions. Okay. Now from this equation, ZnOH plus divided by Zn2 plus and then OH minus is equal to 1.4 into 10 to the power 4. Let me check the value. If the value is not correct, everything is going to be wrong. Correct. So here, if you take log, implies to log of ZnOH plus, okay, minus log of Zn2 plus minus log of OH minus is equal to log of 1.4 into 10 to the power 4 applies to log of ZnOH plus is equal to log of 1.4 10 to the minus 4 plus log of Zn2 plus log of OH. Okay, is equal to this log of 1.4 into 10 to the power 4 plus what is log of Zn plus 2? We know this one. So this part, let me write with different colors. So that is 10.9 minus 2 pH. I'm replacing that value in this value. Okay. And what is log of OH? Log of OH is already I've explained before. Log of OH is equal to negative POH. If you add negative, it will be negative here. So this is POH. And this is minus 14 minus pH. Correct? POH is equal to 14 minus pH is equal to pH minus 14. Correct? So can I replace this with log of OH as pH minus 14 plus pH minus 14. Log of OH is negative of POH. Negative POH is 14 minus pH. There is pH minus 14. Correct. This is correct. So this is log of 1.4 into 10 to the power 4 plus 10.9 and minus 14, 11. That is minus 3.1 minus pH. Correct? Minus 14 and 10.9 is minus 3.1. So this is equal to 1.05 minus pH. That is log of ZnOH plus. This is equation number 2. Please check it out again. So number two is log of Zn2 ZnOH plus is equal to 1.05 minus pH. Okay, so this is the second equation. You please note it down. Is it clear? Please have a look. It is nothing, you can have a try. It is just the derivation again and again. Okay. So third part, it's okay, you can pause the video, you can have a look. And here, I'm just putting the values so that I can remember again. Otherwise, you should have told me, since it's a one-way teaching, I'm using this. Okay. The third one is going to be this. Correct? So the next one is ZnOH2 divided by ZnOH plus into OH minus is equal to 1 into 10 to the power 6. There is a K2. This is K2. Okay. So therefore ZnOH2 log of ZnOH2 is equal to log of 10 to the power 6. This is minus, so I'll put it here plus. I'm shortcutting it. Log of ZnOH plus log of OH minus. Am I correct? This should be minus, this should be minus. So I brought to the right side, it becomes plus. So now, this log of ZnOH plus, log of 10 to the power 6 is 6. This one I'm replacing with 1.05 minus pH. And what is log OH? pH minus 14. So this pH and pH is cancelled. So 7.05, 14 minus 7.05 is 596.95. So there is log of ZnOH2 plus 6.95. This equation symbolizes that the ZnOH2 is concentration is 6.95. This symbolizes that ZnOH2 is always insoluble and it is irrespective of the pH. So if the concentration of the ZnOH2 is more than 6.95, that is ZnOH2 plus is called 10 to the minus 6.95. Correct. So if zinc hydroxide concentration is more than 10.95, if it is more than 10 to the minus 6.95, irrespective of the pH, it will become insoluble. and it has nothing to do with the pH. It's independent. Okay, so this means that zinc OH2 is always in precipitate form above this concentration. But however, zinc is always lower in the concentration. That means ZnOH2 is always in soluble form at lower concentration, irrespective of any pH. Okay, so this is just one interpretation. Number three is log of ZnOH2 is equal to 6.95. Is it 6.95 plus or minus? This should be minus. This is minus. This is number three. Okay, fine. So similarly, I'm trying to find the remaining two. That is, third question is ZnOH3 is equal to, divided by ZnOH2 into OH is equal to 1.3 into 10 to the power 4. Let me check the value. If the value is not correct, I'll be in soup. Okay. Therefore, oh, this log is not there. Oh, a lot of khichdi is there. Therefore, log of ZnOH3 minus is equal to log of 1.3 into 10 to the power 4 minus log of ZnOH2 minus log of OH, correct? So it's equal to log of 1.3 into 10 to the power 4 minus this part, again I'm copying it, this is minus 6.25. So this is minus, so this will be plus 6.95. Okay, and what is negative log of OH? Negative log of OH is pH. This is negative. Have I made a mistake in the previous video? Because this has become negative, I'm confused. Minus pH minus 40. Log OH is pH minus 40. Okay, so this is and this minus and minus will be plus, right? So this is 25.06 minus pH, equation number 4. This is log of ZnOH3 minus. Okay, so you remember this equation? Now 1.3. Let me rough up to here. So here is the fourth part is log of ZnOH3 minus is equal to 25.06 minus pH 4. Okay. Is it okay? Fine. I think now the concept is much clear. Let me do the remaining part. Last part is ZnOH4 2 minus divided by ZnOH3 minus into OH is equal to 1.8 into 10 to the power 1. Let me check the value. It is 1.8 into 10 to the 1. Fine. Therefore, log of ZnOH4 2 minus is equal to the 1.8 into 10. This is log of 18 minus log of ZnOH3 minus log of OH. Correct? Log of 18, log of ZnOH2 is, this part is 25.06 minus pH from this part, and minus log of OH minus pH minus 14. Okay, so this will be 1.8 into 1 log 6 equal to plus equal to minus 9.8 minus twice pH. pH minus pH, correct? That is log of ZnOH4 2 minus. You please remember this one. This is the last equation. So log of ZnOH4 2 minus is equal to minus 9.8 minus 2 pH is not 5. Okay. So here almost all the calculation is over, and it's very funny to say that 50% of the calculation is over. Is it okay? So we have estimated all the K1, K2, K3, K4, K5, and from this equation we have estimated all the different species of the zinc. So look here. Where is my? So look here. So at pH, logarithm of Zn plus 2 is this. It's based on pH. So the second species, the third species, fourth species, and then finally the fifth species. So all the different species of the zinc you can have in different form of pH. Is it okay right now? Okay. Now don't worry, don't get much complex. The ending is very near. Okay. Now the last part of what I'll say is the total concentration. Total zinc concentration, whatever it is in the water, is equal to Zn2 plus ZnOH plus ZnOH2 plus ZnOH3 plus ZnOH4. So 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. This 5 species is going to give the total zinc concentration. Is it clear? For total zinc also, I'll replace with total zinc, or we call it CT. The complete is equation number 1 plus 2 plus 3 plus 4 plus 5. How much it gives? For the pH, this is all the pH are negative. So 2, 3, 4, 5, 6. So this is minus 6 pH. 10.9, 11.95. No, I'm not very good in maths. First is 10.9 plus 1.05. Oh, plus 1.05 minus 6.95 plus 25.06 minus 9.8. So this is 20.26. Okay, so CT, you have a look. This students, this value, I'm having a doubt because this is plus, decreasing, minus. Seems like this should be, I'm very sorry. Let me give it just a cross check. If this is wrong, this is going to be wrong. Let me give a cross check, please. Lot of GnOH3 minus is equal to what is the this is value? That is 1.3 to 10 to the power 4. 1.3 log of 1.3 into 10 to the power minus 4. Minus 4 or plus 4? It's plus 4 minus log of GnOH2 minus log of OH is equal to OH2 is correct, minus 6.95. This is minus 6, so it will be plus 6.9. Minus is there, so that minus 6.95 and this minus will be 6 plus is correct. This is 14 minus pH. Okay, so it may be correct, I don't know. 1.3 into 10000 to log plus 5 is equal to 11. 11 minus 14. Oh, this minus 2.93 plus twice pH. Now I need to work it out. I need to work it out. This log of 1.3 to 10 to the power minus 4. 1.3 into 10000 is equal to log. So this minus, no, this will not be minus, this minus. This will be plus. This will be plus. Correct. Because this divided by this will be plus. Correct. Minus means this will be plus. Correct. So this will be minus 6.95. This is correct. This is correct. Because this side log of zinc minus log of zinc OH minus log of OH. If I brought it over here, it will be plus. So zinc OH is minus 6.95. This is correct. So this is plus. So this is a problem with one-way teaching. log. So minus 6.95. This is correct. This is correct. Minus 6.95. This is correct. Then plus 14. Log OH. And this will be negative. Correct. Log OH is equal to negative POH. 14 minus pH. So it's equal to minus 14 plus pH. Log OH. 1.3 into 100 into this of log minus 6.95 minus up to here minus 14 minus 10. This is minus 16.84. This is plus pH. Minus 16.84. This becomes minus 16. Minus 16.84. Correct. Minus 16.4. This is minus 6.95. Log of OH. Now this part, this I will say log of OH is negative POH. That is negative POH is 14 minus pH. So this is minus 14 plus pH. So then pH should be plus. This is plus. Correct. So 1.3 into 1.0000 to log 4.133 minus 6.95 is equal to minus 14. Minus 6.93 plus pH. Plus pH. This is correct. And next one is log of ZnOH4 2 plus is equal to. I'm just doing the shortcut. What was the consideration? What was the constraint? It is 18. Okay, it's going to log of 18. Since it's going to be minus, it will be plus over here. Plus will be plus log of ZnOH3 plus log of OH. Okay, this is log of 18 minus 16.84 plus pH, and log of OH is minus 14 plus pH. Correct. So this is equal to 18 log minus 16.84 minus 14 is equal to minus 29.58 plus twice pH. Minus 29.58 plus minus 29 point minus 29.58 plus 2pH, and this is minus 16.84 plus. So this total, then it's not going to be correct. This and this will be cancelled, this and this will be cancelled. Okay, so it's going to be, the value will be 10.9 plus 1.05 minus 6.95 minus 16.84 minus 29.58. What the hell? Even my calculator is not a problem. 10.9 minus 6.95 minus 16 point minus 9.58 minus 41 point. So since it's very lengthy, let me do one thing. My dear students, you please try to check yourself and see whether these equations, I believe these three equations are correct. Just please have a check. This minus 16.84 and minus 29.58, and then let me continue my tomorrow class. By using this equation, I'm going to solve the problem. Okay, say for example, the question will be something like, at what pH gene will be precipitated if concentration is equal to 10 to the power 3 moles. You have a STP or effluent treatment plant from industry. It gives out 10 to the power 3 moles. Say for example, at what pH gene will start precipitate, or the exact question may be, I'll tell you, tomorrow we'll solve. Till the minus 3. Okay. See, an effluent treatment plant is there. It gives out 10 to the power minus 3 moles. That is 0.001 moles of zinc. Now you are going to add lime. Why you have to add lime? Because lime is going to increase the pH. So by adding lime, till what pH you have to increase so that the soluble zinc becomes insoluble. So by using this equation, in the next class we'll draw a graph. From the graph we are going to obtain. Okay, but actually I can continue it, no problem. But the thing is, my dear students, you please have a look into this and see this two calculation. If this is correct, it's very easy for me to calculate. Otherwise, not that easy. Okay. So before drawing the graph, up to here, try to grasp the point. We'll discuss and then we'll do the numericals. Okay. So see, today also I learned a new thing, that this type of very lengthy numericals, it is not very easy for me to take it, because number one, I don't have my calculator, I have my iPhone, I have to do typing over there. So if anything with comma and full stop error is there, there is no student for me to rectify during the numericals. Sometimes a minus and a plus gives a lot of errors. It happens. So this is the issue with one-way problem. And I don't want you to give all the solve and give it to you, photostat it, send it, and explain by yourself. I want to teach it on a whiteboard. So some plus point is there, minus point is there. Anyway, up to here, you please check it, and then we'll discuss and we'll do the calculation. And if this is correct, we'll continue with the numericals. Okay? And we have to draw the graphs. Thank you.